Hi everyone, my name is Jeremy Cohen. I'm very excited to be speaking with you here at Cinco de Trino to talk a little bit about using DBT together with Trino. Again, my name is Jeremy. I'm a product manager at DBT Labs. Also, as I'm going to keep joking forever, the head of the office here in Marseille, France. It's a room in my apartment. Okay, goals of this talk. Today's been very hands-on, very practical, like workshop-oriented. So I want to show you how to do data transformation in a much more elegant, modular, reusable, testable way in Trino using DBT. DBT can be orchestrated and deployed using any of the major engines that's out there: Airflow, Dagster, Prefect, and of course our own hosted SaaS offering, DBT Cloud, which we recommend because it offers the most dedicated and integrated experience for developing and deploying with DBT. I'm going to be showing and demoing later using DBT together with Trino, specifically Starburst Galaxy, thanks to the Starburst team, to try to show some of the most important features together using this sample dataset that ships with lots of different database vendors, TPCH. It represents a real dataset for a sample dataset for what you can imagine to be a real company, a real organization selling orders to customers and so on. We'll take that for a spin. Throughout this presentation, and certainly for the next couple slides that I've got, I'll also be answering the questions of what is DBT actually, what do we mean when we're talking about data transformation, and why are modularity and testing so important when doing data transformation. If this is your first time ever hearing about DBT or ever hearing that it can be used together with Trino, you're in the right place. Okay, a little bit of history, not too much. Cloud warehousing made it really cheap and easy to transform data in place. So unlike kind of like legacy system here with Postgres, SQL Server, Oracle, and so on, where there's really high costs for storing data, multiple copies of data, as well as for computing on-the-fly aggregations, there was this need to have these heavy transformation pipelines upstream of the data actually landing in the warehouse, in the database. But because these are two different teams, a team of analysts over here and a team of probably data engineers over here, anytime we need a new cleaning step to take place or a change to the opinionated transformation happening over here, the analyst team has to throw that request over the fence, over the wall, and hope that the engineering team catches it. So it is not as efficient as the new ELT-based approach that we've been advocating for with DBT at the center of transformation that can take place in the warehouse. It's all SQL first because of the advent of the data warehouse vendors and, crucially, Trino, among others, in the lakehouse capabilities and the ability to query data wherever it lives. Opinionated transformation logic can be written by an analyst in SQL to access the data where it lives and then still clean it, prepare it, get it ready for querying inside a BI tool. DBT's viewpoint is, let's try to get the best of both worlds. Let's write all of our transformation logic in SQL because that's what's accessible to the most number of people, but also work like engineers with all the flexibility of custom coding and the power of never writing boilerplate repeated code yourself, never solving a problem yourself that someone else has already solved and open sourced and made available so that you can always work with the best tooling that the community provides. It is really important, this step that takes place in between the raw data just being loaded or even accessible to the data warehouse and the final data sets. Now, a member of the DBT community and a DBT and Trino super user, Michel, had this image in a recent blog post that he put out about real-time data transformation with DBT and Trino. And I really love this image because it shows like Trino can actually be the conduit between everything that DBT has access to and all of the data wherever it may live via all of these different connectors. Okay. DBT, a lot like Trino, is open source at its core, and then there is also a cloud offering for the full experience. So all core SQL compilation, execution, transformation, testing, documentation, all of that is in the open source DBT core framework. And then there's a fully managed SaaS experience for developing, deploying for folks who want to have access to DBT Cloud as well. Okay, so I mentioned the word community earlier. I do want to call this out because it is worth stating that DBT's adoption has been growing quickly and organically for many, many years, since 2016 when the project initiated. It's a cool exponential line. but we've now got over 11,000 companies using DBT, and it's open source DBT out in the world, over 1,800 customers of DBT Cloud, and more than 28,000 folks who hang out in our DBT community Slack. And this is true for DBT and Trino as well. So there's increasingly many folks who have starred and are using the DBT Trino adapter, the way that DBT is able to talk to Trino, which is maintained by the folks at Starburst. There are over 300 people who hang out in the Presto Trino channel of our community Slack. That's where I caught Michelle's blog post. And you can see there's a line that's going up and very much up and very much to the right for usage of DBT together with Trino. Let's talk a little bit about how it works. I've mentioned things like not writing boilerplate data engineering code, but it would be worth getting into a little bit of the specifics just before we get into the actual demo itself. So 4 pieces here: development, documentation, testing, and deployment. Development. All that you write in a DBT model is a select statement. That select statement should return a data set, and that data set represents something that's conceptually meaningful. Business logic. I want all of my orders that haven't been deleted. That's it. Orders.SQL, that's my orders model. When it actually runs in the warehouse or in the data platform, DBT is going to template out that boilerplate, repeated, not interesting logic of, okay, this is going to be a table, so create table, location of that table as, and then my same model SQL. It's super repeatable and idempotent because I'm not writing drop, alter, create statements in my DBT project code. I'm just describing the data set that I want to be returned. My orders model is select star from stage orders, where is deleted is false. Even this isn't all the way there because we want to actually replace that raw data reference with this ref function that DBT makes accessible. This does 2 really important things. It makes it possible for me to run this in different environments: development, staging, production, and DBT is going to dynamically template out the right environment based on where I'm running, the right place to select that data from. And DBT is able to keep track of dependencies automatically because I've used this ref function. So now, because orders depends on stage orders, when I go to run these models, DBT is going to run stage orders, and then whatever depends on orders. Here's me running this in development. Here's me running it in production. Notice that I didn't change my model code at all. DBT just knows how to run it based on where I'm running it. It's important, now that we've talked a little bit about those dependencies and that ref function, to actually be able to see those dependencies and visualize the state of the project as a graph, as a directed acyclic graph, or DAG. And here it is. We'll take a look at that in a couple of minutes with our real demo project, but DBT is able to automatically generate this DAG based on the current state of the project and let you iterate over this to make sure things are being used and reused and building on top of each other in the most modular way possible. Testing. It's really important that we don't accidentally end up with nulls or dupes or other unacceptable values in our data sets. DBT has these out-of-the-box tests for things like uniqueness and values never being null or never being outside of an acceptable set. But it's also really easy to write our own test cases, and DBT will just run them at the right point in the DAG, at the right point in the graph where they need to be tested. Finally, this isn't something we're going to be able to get into in the demo today, but it's that next level. Once we have the right code in our project, once we have the right model code, the right tests, being able to schedule those models to run every single day, being able to test changes to those models in a staging environment, CI, or as soon as the model has changed, being able to run it again in production, just CD, continuous integration and continuous deployment, being able to do the whole thing in version control with logging and alerting. This is something that DBT Cloud in particular can help a lot with. All of this is possible with an Airflow or a more generic orchestration tool as well, but it's really where Cloud's opinionated deployment infrastructure can shine. Okay, that was a lot of stuff. I want to make sure we get some time to sink our teeth in. So without further ado, let's start demoing. Okay, I'm seated, fingers at keyboard, coffee's in the mug, we're ready to go. This is the Starburst Galaxy interface, which is pretty cool. This is the sample TPCH dataset that we're going to be taking a look at today. Customer, line item, nations, orders, parts, part suppliers, I think, regions, and again, suppliers. So let's say I want to write a SQL query that is going to get me the total order amount by customer by month, right? How much money did each customer spend at my store in a given month? Not too fancy, right? Not too crazy. Well, here we go. This looks pretty straightforward, but in order to build up to here from the actual raw data sources, the actual raw tables that I've got in the database, I had to write a little bit of SQL to do things like rename columns, or maybe combine columns together to get some unique identifiers. I actually had to figure out what gross item sales amount means, right? I need to figure out what money means, how much money someone has spent at my store. Does that include tax? Does that include discounts? All the items added together or any items excluded? So yeah, this is, like 426 lines of SQL later. Either you're looking at this and thinking, wow, Jeremy, you're really good at writing SQL, or you're thinking, wow, Jeremy, that does not look good. And I hope your answer is the second one, because as soon as I need to make some adjustment here, or as soon as I have a question like, did I make sure there weren't any duplicate customers that needed to be merged together, all of a sudden I have a real excavation, a real archaeological project ahead of me to go through this and try to figure out where is the right place in here to make sure that there aren't any duplicated customers. Or like gross sales amount, we need this in 4 decimal places instead of 2. Okay, this is what we started with. I hope I've convinced you that this is not the way to go. This is what we're going to try to end with. Just one table in a schema that I've created using dbt I can really straightforwardly filter and actually answer a much more complicated question than the one that I was able to answer here. Here I was just trying to get 1 row per month customer total sales amount. If it's easy to get something that simple, then it becomes just a little bit more work to get something much more complicated. Like, well, how about comparing this month's amount to last month's amount? And then figure out if the customer has downgraded or churned or. So I don't want to keep the secret any longer. This is work that I've done using dbt. I've got a dbt project here, which has a lot of files in it, a lot of stuff going on. We'll walk through it together. I've also been using dbt on my command line, specifically the plugin for Trino, dbt Trino. Okay, let's dive in. For each of these source tables, I've defined a source in dbt. So the name is tpch, it's in this catalog, it has this schema, and then for each table, I've been able to say, for the orders table, here's my description of the orders table, here are some columns, here are some tests that I want to run against that table. The tpch dataset is super standard, hopefully doesn't have tons of nulls and duplicates flying around, but your real data in real production probably does. And it's important to know that it does as soon as possible. I'm also testing foreign key relationships, and in some cases I could also test for accepted values as well. In the case of tests that I think have a decent chance of failing, I could even say, I just want these to warn rather than raising errors, and so on. These are my source tables. For each one of my source tables, I'm going to have a staging model. So for tpch customer, stage tpch customer. The main goal here is just to rename columns so that they're snake-cased in a way that I like, and then they're consistent between the different tables, and it's that much easier to join on them later on because they all have the same names, but it could be doing something a little fancier as well. Let's go ahead and run all of my staging models. So one way you can do this is the name of the folder, dbt run-s, which stands for select, oops, I'm so sorry, and not marks.staging, staging. There we go. So this is going to actually connect to Trino, and behind the scenes, what dbt is going to be doing is for each of these models, it takes the SQL that I've written here, it resolves the source call. It's a lot like ref, what we looked at earlier, and it's actually going to create tables in the database. We can pop in and see the compiled SQL that dbt is running for each of these. So this is compiled, you see it replaced the source, and the actual SQL that it actually ran, wrapped in create table analytics dbt Cohen. And you see this is here because I'm running it in development. This is my schema name. If you were to run it, it would be dbt you instead of dbt me. There we go. I've successfully run all of my staging models. So now what I can do, instead of having to navigate the wacky column names that were in here before, I can just say select customer key from analytics dbt Cohen stage dbch customers. All right, not so bad, not so shabby. One really important reason to do this is we've made sure that there's a single point of entry for every raw source table into my analytical project. So if there are problems with those tables, I can solve for them right in the staging layer. Let's actually run this with Turbo. Looking good, looking good. Ooh, we found one failing test. We have a failure in a test that nation key is unique in stage TPCH nations. I wonder why that's happening. Maybe it's because I added a duplicate intentionally, but this really does happen in real source data systems out in the world, and so it's really important to test them as early as possible at the source level or potentially in the staging layer right here. What we can do in a bit is just add a little filter, or in my case, remove the code. But I do want to show one important thing, which is once we've built the staging models, we're actually going to go up to a higher order of definition, which is we're going to define things like dimension customers, dimension parts, dimension suppliers, fact order items, and fact orders, including some more complex transformation here, summing up the total item amounts by order, joining those in, joining these together. So one really important thing to be able to do is actually prevent ourselves from building those downstream bigger models, the ones that have a little more going on, if one of my tests, one of my assertions about the upstream model is no good. So what I'm going to do here is just say build everything up to dim customers. So this is going to pick all the models that are upstream, that are parents of the dim customers table, and then test them, run them, see if everything's good to go. While that's happening, I know that's a little bit tricky to visualize, which is great that we've got these auto-generated docs, this auto-generated documentation site to help. Again, this is our TPCH source. These are the models that we're looking at here. So what I can do is actually pop open the lineage graph and say, show me everything upstream dim customers. That includes stage TPCH nations. And that test is still failing. So what DBT is going to do is it realizes that this test failed, and so it's going to skip building dim customers because something upstream of it is no good. This is the dbt build command, which combines run and test together. As soon as I pop in here and say, let's not have bad data anymore, I can rebuild and hopefully everything should be in really good shape. That's this. We could even take a zoom out and look at our whole project here. We've got a seed table with some months in it. We'll take a look at that in a second. We've got some source tables, staging models, these intermediate and then dimensional models that we've got here, dim, fact, and then even an exposure which reflects that these DBT models should actually be pushed into a dashboard somewhere. They're actually going to be used in downstream BI. So that instead of our business intelligence tool needing to store some SQL like this or generate some SQL like this, it's going to be able to generate SQL that looks just like this instead. Okay, so we've talked a little bit about the docs, about models, about tests. This represents one form of modularity, right? Anything that we are doing in the nations model, like fixing a dupe, is something we now don't need to fix inside of the customers model or anywhere else. There's another form of modularity, which I hinted at earlier, and that is the ability to template code, to template SQL, using macros, using these reusable snippets and functions inside DBT. Here we go. One place I wanted to look here is in the order items model. I'm doing a lot of interesting logic around deriving prices and with tax, without tax, and so on. But I'm using this macro here called convert money. And this code is just going to be templated in to each place that I'm running order items, that I'm calling this macro. We can see here. So instead of seeing convert money, we'll actually see cast as decimal 16.2. The nice thing about this is if someone in the accounting team tells me, oh gosh, like we need to go store all of those numbers in 4 decimal places instead of 2, rather than that being a month-long effort of Command F, of searching down all the places we've ever written decimal to, I change it in one place and I rerun my models. And it all just works at 4 decimal places. This is a very simple kind of macro. There are some fancier macros as well, which we can take a quick look at. Let's look at something that is really annoying to write in SQL, which is a pivot. You frequently find yourself writing code that looks maybe like year, sum, case when, product equals product 1, then amount, else 0, end as product 1 amount. And as soon as I hit copy paste here, right, you know that we're in for trouble. Product 2, product 3, product 4, product 2. Has anyone ever written this before? Something like this? dbt can help using the same kind of idea, the same kind of macro, the same kind of dynamic templating, where instead of writing this as over and over again, I actually write it with a loop. For name in part names, sum case when part name equals the dynamically templated name, and so on. And I'm actually using a macro here to dynamically go and grab the part names. And it's a macro that I didn't write. It's a macro from a package, specifically the dbt utils package, which you can see here. And this get column values macro. dbt lets you borrow or reuse macros that someone else has written using Jinja that's a little fancier than the code I had over here. With this in place, I'm just going to go ahead and re-enable this model. Yearly parts pivot. You'll be able to see the code that's dynamically templated to loop over some case when, some case when, some case when. And there we have it. By year, for each of these different products, how much did we sell of each one? Super common in BI use cases. Let's take a look at one that's even more common in analytical use cases. This is doing something a little fancier than that first query. It's not just for every month that there was an order, how many, like what's the total amount of orders for that customer. It's really for all months, including months where the customer may not have had an order. This is really important because it lets us be able to do things like compare the current month to the previous month and determine if there's been a churn or a downgrade or an upgrade or so on. So let's run our monthly customer rollup. And this is actually going to be pulling a spine of months, which we've defined in a seed file here. What's a seed? It's just an easy way to load some CSV static fixture data into the database. And Trino here is, Galaxy I should say, is also no exception. Those are some dates. Pretty cool. And we've got monthly customer rollup. For every month, at least the ones in 1992, customer gross item amount compared to the previous. And it's that easy. I can come in here in my BI tool, wherever, and say, okay, I just want to look at customers that had a previous month, or that didn't have a previous month, or that downgraded, or that upgraded, and so on and so on. It's not super powerful to look at this for just 1992. I could come in here and just keep adding rows to my static CSV file, but much more compelling than that is actually using a macro, also from dbt utils. This macro says, create for me a table with one row per month between January 1st, 1992 and August 2nd, 1998. That's the limits of the TPCH dataset that we're using. I'm going to come back in here, and instead of some months, let's make this all months, and run both. And that macro is going to template out the right code to do this thing on Trino. It's not pretty code, I'll say that much. It looks a little like this. Cross joins, weird filters in a way that I don't totally understand. And yet what we end up with is 1 row per month for every month between those two dates. The really cool thing about this macro is it's actually written so that it works on all databases, at least all supported databases. This is me in dbt Cloud using the development IDE, and this is me connecting to Redshift, my Redshift. I've got the exact same code here. I'll copy paste it just so you can believe me. I'm going to run this against Redshift, and it's actually going to run genuinely different code behind the scenes. And yet it's still going to work. One cool thing about the IDE is it's a lot easier to compile data dynamically and see the results. You may notice that there is a date add here that looks a little bit different from the date add here. That's all abstracted away from me as the end user of dbt. I get to just put this code in and have it just work. I should start seeing data for not just 1992, but 1995, 97, 98, and so on. One last cool thing that I want to show. This is more Trino than dbt, but it's really both of them together. Let's say this wasn't just a macro that magically worked across different databases. Let's say this was a table that genuinely only lived inside Redshift, and I needed to get access to it. On a different data platform, I would need to load this. On Trino, I get to just say, hey, that table, it's in Redshift. My catalog is Redshift Sandbox. This is using the Redshift connector. I'm going to enable this. I'm going to totally replace this with a call to a source, because that's actually what this is. It's the all months table. It lives inside of Redshift. I'm going to run all months and everything that depends on it, which is to say, recreate this table, not using my dynamically templated macro code, but actually pulling it out of the version here that lives inside of Redshift, and then rerun my model as well. Pretty cool. And the fact that this is actually pulling from Redshift, totally abstracted away from me, the end user. I get to just get access to my source data in all the ways that I need it. Let's go ahead and recreate my documentation here. And we should now see a couple new additions based on the work that we've done over the last few minutes. What dbt did was go and run some metadata queries against the source tables, against my real tables, and I've now got a slightly more complex DAG where there is a Redshift powered source feeding into all months, feeding into monthly customer rollup. And if I wanted to go ahead and expose this model in a downstream BI tool, it just looks like powering that BI tool with a query like this. And once it's in production, a query like this. That's what I've got to demo for you today. So I hope you got a chance to see auto-generated documentation, how it keeps up to date. I can regenerate it based on the new refs and sources I've added along the way. The process of developing with dbt, both locally and in dbt Cloud, how we were able to keep our definitions and our tests modular, both modular for the DAG and also modular for not repeating ourselves with the same code, the same decimal values over and over again, using macros and packages to level up our SQL, and getting easy access to data sources wherever they live, even if it is in another data platform, thanks to Trino. Not included in this demo, the full mechanics of continuous integration and deployment in dbt Cloud, starting to really dig into the metadata that's produced by dbt. There's a lot of really rich and valuable stuff that happens because we've been running these transformations over and over, running these tests, and doing incremental processing at scale. So much bigger than the tiny TPCH dataset we were using, and being able to power it with other connectors that Trino supports, such as the Delta Lake connector. There's so much more to show and play around with. We're only able to look at a tiny slice of the dbt-powered transformation workflow on Trino, but I hope that it's been enough to inspire you a bit and want to check this out a little bit more.